Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, have a nice day. Today we will learn about looking for velocity using an instant center method. This continue about our lesson before for instant center location or position. For this time, we will discuss about usability for instant center location for looking velocity value. This is for definition about velocity using instant center method. The velocity of a point on object rotating on the center of rotation is the object angular velocity multiplied the distance of the point to the center of the rotation. It means the linear velocity is equal to angular velocity multiplied to distance or radius to the center of the rotation. Based on this principle, then the velocity of a point of the mechanism is the product of the angular velocity. The object where the point is at is instant center of velocity or instant center position. There is a basic principle that must be considered to looking for velocity using this method. The first principle is that the magnitude of the linear velocity on rotating object is directly to proportional between the radius of its rotation. It means greater of linear velocity will be increase the radius of the rotation. Now the second principle is the linear velocity is perpendicular to the radius of its rotation. You can look the picture below. The linear is VA, linear velocity is A, is perpendicular to the radius of the rotation, like this. This is a linear velocity. This is a radius for rotation. This is for instant center. The third principle is the angular velocity and at instant center velocity is the same everywhere in the same object. If we have the instant center for this point O1, 2, and then the angular velocity for point A and B, it will be the same velocity between the same object. Same object is mean is from instant center O1, 2. You can look the illustration. Point A and point B are visible on the object 2. This is object 2 for example. With the instant center velocity of object 2 being point O1, 2, the velocity of the point A is the angular velocity of the object 2. We can call the omega 2. We can call the omega 2 multiplied to radius of rotation. Radius of rotation from point O1 to this position. So that for linear velocity we can conclusion equal to omega 2 multiplied to a radius from point O12 to A. This is for the radius. Is this same condition with from B position? The angular velocity at point B is also equal, so that the velocity in point B is equal to omega 3 multiplied to radius from point O1 to B position. So linear velocity from B point is equal to omega 3 multiplied to this radius from O12 to B position is same to linear velocity in A position. Multiple between omega 2 to length of radius this position O12 and A. The fourth principle: the instant center velocity of two objects has equal linear velocity in direction and magnitude. You can look the picture below. In the following discussion, the object angular velocity is also tangent. Thus, the angular velocity for omega 2 equal to tangent gamma 2. In this also same with angular velocity for omega 3. Omega 3 is equal to tangent gamma 3. Based on the basic principle, through the center of instant center velocity, we can find the angular velocity of its object. And then you can look for illustration for the picture. The following example with 4 link. This link have 1, 2, 3 and 4. This is a 4 link mechanism. If angular velocity of object 2 is known, we can determine the angular velocity for other object. For example, for omega 4 and omega 3. If we know the angular velocity from the object 2, and we want to find the angular velocity from object 3, then the instant center velocity that we are using the O23. We can using O23 for find the velocity on object 3. This is for object 3. So the velocity from O23, VO23, we can say in this equation. VO23 equal to angular velocity from object 2 or omega 2 multiple radius from O12 O1 O23. This is for radius in velocity VO23. And then if we know the tangent from omega 3, we can say the velocity from this area VO23 equal to tangent gamma 3 multiplied to this radius O13 O23. This is radius, and then equal to omega 3. This is omega 3, sorry. Equal to omega 3 multiplied to this radius O1, 3, O2, 3. This is for radius, for velocity O2, 3 also. By to combination about the two equations, we can calculate the equation to find the angular velocity for omega 3. Omega 3 equal to omega 2 multiply radius from O1, 2, O2, 3. This is this radius divide to this radius. This is a conclusion equation from two equations before, and then we can know about the angular velocity in this position or omega 3. And then to find the angular velocity in position object 4, we can use angular velocity from omega 3 and omega 2, this position. There is two ways will be explained as follows. Look at the illustration for find angular velocity in this position or omega 4 by using angular position for omega 2 or object 2. The internal center of velocity for omega 4, this position, used by instant center on point O24, this position. The value about angular velocity omega 4 is obtained by mean as this equation. Linear velocity from O to 4, this direction, is equation between omega 4 multiple radius from O14 O24. This is this radius, and equal to angular velocity from omega 2 multiply this radius, O12 O24. And then we can conclusion about this equation to find the angular velocity from omega 4 or angular velocity in position link 4. Omega 4 or angular velocity in link 4 is equal to omega 2 angular velocity link 2 multiply with radius, this radius O12 O24, divide this radius O14 O24. Now we can find value about angular velocity for omega 4 or angular velocity in link 4 position. Now we use for second way or second method for finding angular velocity in link 4 or omega 4 by using omega 3 position. This is from omega 3 position, and then this is for omega 4. We can look to this illustration with using about velocity on point 034. This is this point about of linear velocity. This point is equal about from position omega 3 and omega 4. So we can take a conclusion about position linear velocity position for this position is equal from omega 4 multiplied O radius O 14 O 34. This is for radius for omega 4. This equation is equal to this position omega 3 multiplied of 4, that's radius, O13 O34. After that we can calculate for this equation to looking for omega 4 or angular velocity in link 4. This radius move to the right side, so we can find omega 4 equal to omega 3 multiply radius for O13 O34 divided to radius O14 O34. Okay, this is another sample for this lesson. This is same link for link mechanism. As an illustration, consider the following example problem. The mechanism in the following figure is for link. 1, 2, 3, 4. This is have 4 link. Of course, the connecting link is rotated at speed omega 2 to counterclockwise. The connecting link rotate as a speed velocity or angular velocity at omega 2 counterclockwise for rotation. We will find the angular velocity of link 3 and 4. The solution of this problem will be done with two methods. Now the first method is we must find the angular velocity for link 3 and 3. After that we can take for angular velocity in 4 position or for link position number 4. Because the known angular velocity is omega 2 in link 2, which correspond to the connecting link 2, and the angular velocity to be found is omega 3, which related to connecting 3. The instant center velocity used is the instant center velocity associated with connecting link 3 and 2. So in the center velocity used to find omega 2 and omega 3 is known O12, O13 and O23. Then we find the outlet instant center of velocity between the connecting link 2 and 3, namely on point O23, which is also point A, in order to obtain. We can look for the equation. If we looking for a velocity in a position, it will be same equal like omega 2 multiplied for radius O12 O23. This is for radius in velocity a position, yeah. Or VA equal to VO23. For a link 2, we can take some angle from omega 2. We can use the following trigonometric relationship for tangent 2. Tangent gamma 2 equal to velocity in a position divide radius link 2. This is the equation for tangent gamma 2 equal to V O23 divide about the radius O12A. This is for radius, yeah. Or for omega 2 equal to tangent gamma 2, like this, yeah. Now look at the picture below. It appears that the vector of velocity from O to 3 is also related to link 3, yeah. We can determine the angular velocity of link 3 with the following this formula, yeah. Omega 2 equal to tangent gamma 3 equal to VA, velocity in a position, divide this radius or O12 O13, yeah. So that we can calculate about the next for locking angular velocity in link 4. In this case, omega 3 has been known before, yeah. Therefore, the instantaneous velocity used to search about omega 4 with omega 3 already known, namely on O12, O13, and O34. Yeah. After that, we can determine velocity in point B or O34 associated with connecting link 3 and 4, link 3 and link 4, so that we can take some conclusion about the velocity in this position or B position. VB equal to tangent gamma 3 multiple radius O13 O34. This is radius for VB. For tangent gamma 3 is equal to tangent gamma 4 because is used about instant center same position, instant center O13. After that, we can take about omega 4 for this position is equal to tangent this position or gamma 4. Omega 4 equal to tangent gamma 4 or equal to this velocity divided about the radius, yeah. So gamma 4, tangent gamma 4 equal to VB divided O34 O14. This is for radius, for omega 4. Point J is located in the connecting 3, yeah. So the velocity of point J, we can take some formula, but from tangent 3 also, This is a tangent ray also. This is have a same angle but gamma 3 because we use the same instant center O13. So for velocity in C position, we can take equal than gamma 3 multiplied to this radius O13 C O13 C. Yeah. Now the second method to looking for omega 4 or angular velocity in length 4. Then just look for the angular velocity at the connecting link 3. First of all, we determine instant center of velocity on O24. So we get the following about the point. Point A, this point apart from being located on connecting link 3 is also located on connecting link 2 on point B. Besides being located at link 3 is also located on the connecting link 4. Thus, the instant center velocity of O24 can be used in the following this equation here. VO24 equal to omega 2 multiply the radius O12 O24. This is for radius. And then omega 4 equal to tangent gamma 4 equal to velocity of VO24 divide the radius O24 O14 O24. So we can take conclusion, but velocity in point B is VB equal to omega 4 equal multiplied the radius O14 O34.
In this video, we'll be discussing about the instantaneous center method of velocity analysis. By instantaneous center, we mean that a point about which a link is assumed to have pure rotation. So we can consider the different types of motion that can occur in a mechanism. So there can be three types of mechanism. Basically, this already you are knowing. So one is pure rotation, pure translation, and general plane motion. So for all these three types of motion, I can assume there is a point about which these motions are occurring such that this is pure rotation about the point that we are considering. So first you are taking a pure rotation where link 2 is there, which is rotating about the point A with respect to the fixed length. So this itself is a pure rotation about this point. So I will be calling this as the instantaneous center for this rotation, and I will be calling or marking it by I. So in the second case, here we are having a pure translation. So the path of the block 2, here you are having a relative motion which is translation for 2 with respect to the fixed length 1. So the path is always straight. So if you are having this, here it is rotation and this is happening about this point. So here you are having a linear path, and you are knowing that linear path is equivalent to a circular motion which is having infinite radius of curvature. So here also you can, in a similar way, you can assume that this is a linear path which is having the point of or the radius of curvature which is infinity, or point of that curvature is lying at infinity. So here the instantaneous center will be at infinity. So this will be lying at infinity. So the instantaneous center for this motion will be at infinity. And here we are having a general plane motion. So link AB is having some combined rotation as well as translation in the plane. So here you can have the velocity of A which is directed in this direction and B is in this direction. So for such an instant, for the motion of link AB, you have to locate the instantaneous center, and instantaneous center will be obtained by drawing perpendiculars to the velocity vector. So if velocity of point A is in this direction, then I can draw perpendicular to this one. This will be coming in this direction. In similar way, for this velocity vector of point B, I can have perpendicular. So this will be meeting at this point, and this will be giving you the instantaneous center for this general plane motion. So here also, in the previous two cases also, if you are having pure rotation about this point, for this point the velocity vector, this will be in this direction and perpendicular will be passing through the instantaneous center. And here also velocity vector is in this direction and perpendicular will be passing through the instantaneous center, which is at infinity. So you will be using this instantaneous center for finding the or for conducting the velocity analysis that you can understand through a problem. So here we have a problem on 4-bar mechanism which you have to solve by the instantaneous center method, and at the end you have to find the angular velocity of link BC. So first you have to understand, for a mechanism which is having n number of links, the instantaneous centers is given by n into n minus 1 by 2. So here you are having a 4-bar mechanism, n equal to 4. Therefore, the number of isenders will be equal to 4 into 4 minus 1, 3 divided by 2, which is equal to 6. So for this 4-bar mechanism, there are 6 number of isenders. Next step, we will be naming all the isenders. So isenders can be named in such a way that, so 4 number of links are there. So I will be writing the first link, and it can make combinations with the other 3 links. That is I12, I13, I14. Next I will be taking the second link. This can make combination with the other 3 links. So I21, so already we have written the I12, so I21 will not be there, I22 will not be there, then you have I23 and I24. Similarly, I31 will not be there, already we have I13, 32, already we have I23, I33 will not be there, and then you have I34. And next I41, already we are having I14, I42, I24 is there, I43, I34 is there, and there is no I44. So the 6 isenders are there, and we have named all the isenders here: I12, I13, I14, I23, I24, I34. And you have to mark all or locate all these instantaneous sender on this 4-bar mechanism. That is if one part of question. So here in a similar way, you have to name these links also, number the links also. This is first link, and this is second link, this is third link, and fourth link. So you'll be locating these isenders. So link 2 is having a, so this link 2 is having a pure rotation about this point A. So the instantaneous center of rotation between links 1 and 2 is located at this point, and this point will be giving you the instantaneous center of rotation I12, that is between links 1 and 2. In similar way, you can have I23, the instantaneous center of rotation between links 2 and 3. So similarly, this is I34, and similarly this is I14, which is equivalent to I41. So out of this 6 isenders, already I have located I12 is marked, I23 is marked, I34 is marked, and I14 is marked. So remaining things are this I13 and I24. So how you can locate these isenders, for which you will be using the Kennedy's theorem. So you are knowing that the Kennedy theorem, if 3 bodies are having relative motion, then their instantaneous centers will be lying on a straight line. So here if you are seeing, you are having the instantaneous centers I12 and I23 here. Out of this, the common number is 2. So out of I12 and I23, if 2 is going, then you are having 1 and 3 remaining. So you are having 3 bodies, 1, 2 and 3, which are having relative motion. Then I12, I23, then the third, that is I13, will be lying in this same straight line. So you can have a straight line which is extended in this direction. And similarly, if you are looking here, you are having I34 and I14. Out of that, if the number 4 is going, then you are having I13. So in this line also I13 will be coming. So you can have the line which is extended, so that will be giving the intersecting point at this point. So this will be the isender which is giving I13, that is you can obtain using the Kennedy's theorem. In a similar way, so now you have marked or located the I13. Next you have to mark the I24, for which I24 will be at the lying on a straight line that is connecting I12 and I14. One will be going, then the remaining terms will be 2 and 4. So I24. Similarly, I23 and I34. Common number is 3. Then the remaining will be I24. So I24 will be lying on these straight lines which are extended. So I'll be extending this line. So this will be lying in this line, and also this will be, I will be extending. So this will be lying at this point. So I can name this as I24. So now the first part of the question is over. All the I centers are located. This is having 6 number of I centers, and we have named it properly and located also. Next, you have to find the angular velocity of the link BC. So for that, link BC is numbered as 3. For that, first you have to get into or understand the motion of link number 2. So link number 2 is this one. It is having pure rotation about this point A, and this will be having this rotation. Angular velocity is given, which is rotating at 100 rpm in clockwise direction. So point B will be having a velocity vector which is perpendicular to this line joining A and B, and the velocity vector will be coming in this direction. So I'll be marking that velocity vector here. So this will be the velocity vector. This is velocity of point B with respect to A. Since A is a fixed point, I am calling this as VB itself. Similarly, if you are looking this link or output link or link number 4 or link CD is also having a pure rotation about this point or in this instantaneous center. So this will be having a velocity vector which is perpendicular to line joining C and D in this direction. So that velocity vector also I will be marking here, and this velocity vector I will be named as velocity of C. With respect to D it is, which is a 0 velocity point, so I will be simply naming it as VC. So if you are looking, the instantaneous center I13 can also be obtained by drawing perpendicular to the velocity vector. So if VB is in this direction, then you will be drawing perpendicular, since link number BC is having a general plane motion or link 3 is having a general plane motion. So I can draw a line in this way and also a line in this way. So this will be intersecting at this point, and that will be giving the instantaneous center I13. So now you can, from the given data, you can evaluate the velocity of link B. It is actually VB with respect to A, which is equal to link length AB into omega of AB. Omega of AB is given in RPM, so you can convert into 2 pi n by 60, where n is 100 RPM, and then this will be equal to 10.47 radians per second, where this n value is 100 RPM. So if you are substituting this one, then AB is equal to 300 mm. So all this will be constructed based on a scale which is known as configuration diagram. So first we will be making the configuration diagram for this one. So if you are having the length AB is 300 mm. So if you are substituting that one, then this will be equal to 300 mm, or this is 0.3 meter into 10.47 radians per second, which is equivalent to 3.14 meter per second. This will be the velocity of point B. And this point B is coming at the end of link BC, which is having a general plane motion, and that is assumed to have the instantaneous center at this point. That means general plane motion of BC can be assumed to be about this point, which is a pure rotation about this point. So about this point you can join I13 to B, then you can get some distance from this configuration diagram itself according to the scale you are using. So I1B will be the distance into you are addressing the link BC. So this will be having omega BC, angular velocity, which you have to find. So I13 into omega BC will be giving you the same velocity. So this VB you can equate to I13B. This is the distance from the instantaneous center I13 to point B into omega BC. This omega BC you have to evaluate. So if you are measuring the distance I13B and then you have to convert into the scale. So if you are measuring, you will be getting this length after scaling. This will be equivalent to 0.5 meter. That is, if AB is 0.3 meter, and you can have a scale, this is equivalent to 1 centimeter on this configuration diagram will be giving you 100 mm. Then all lines will be the AD can be represented by 6 centimeter line, and in similar way you can draw all lines. So here I13B will be representing 0.5 meter. This can be obtained by this 5 centimeter line on this diagram. So you have to evaluate omega BC here. So omega BC will be equal to VB divided by this distance, that is 0.5, and that will be equal to 3.14 meter per second divided by 0.5, that is omega BC will be equal to 6.28 radians per second. This is the answer for the angular velocity of link BC, which was asked here. So if you are asked also about the angular velocity of link CD, then you can use this velocity vector VC. So here the C is a point which is common to link BC as well as link CD. So the velocity of C can be addressed with respect to the instance center and also with respect to this point. So you can write the velocity of point C as I13 to C distance into omega BC. So you already are having omega BC now, which is 6.8 radians per second, and I13 to C distance you can measure from this diagram, which is equal to the length CD into omega CD. So from this you can evaluate this omega CD also. So this is the instantaneous center method of velocity analysis for a 4-bar mechanism.
Okay, that's all for our lesson today. For instant center method to looking for velocity. If you have any question, don't hesitate to ask me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.